Okay, welcome to part 3 of our lecture video series from Monday, March 20th, where we are now going to practice balancing chemical reactions by doing a few examples together in this video, together in spirit. So let's look at the reaction of P4O10 with 6H2O forming H3PO4 aqueous. And this is not gaseous, this is solid. Oh, given away. All right. So just like we did before, we need to keep a tally of what is going on our reactant side. So what's happening on the left-hand side, or how many of each element we have on the left-hand side of our reaction, and what we have on the right-hand side. So let's start by looking at phosphorus. So based on the subscript of phosphorus on the reactant side, I have 4 atoms of phosphorus, whereas on my product side, based on this subscript, I have 1 atom of phosphorus, meaning I need to quadruple the quantity of phosphorus, and the only way I can do that is by placing a quadrupling amount in front of my H3PO4 product, meaning I have now quadrupled the amount of H3PO4 molecules that have been formed. Okay, let's follow what that's done now. So this has now, looking at our product side, let's look at our hydrogens. So in each H3PO4, we've got 3, but I have 4 H3PO4s. So 4 times 3, that is 12 hydrogen atoms. So looking at my left-hand side, the only compound that contains hydrogen is my water. So if I here have only 2 atoms of hydrogen, then I need to multiply my source of hydrogen by 6, meaning I need to up the ratio of hydrogen molecules to 6 water molecules, in order to get me the quantity of hydrogen that I want. 6 times 2, 12. Okay, let's look now at oxygen. Doesn't matter where. So let's start on our reactant side. So I have in P4O10, I've got now 10 oxygen atoms. However, on my reactant side, P4O10 is not my only source of oxygen. I've also got water here. And I have to take into account the fact that the source of my oxygen, being my water molecule, has been multiplied by 6. So this is also going to affect my oxygen. So I have 10 oxygen atoms from my P4O10, and I have now 6 times 1, 6. This leaves me with 16 atoms of oxygen. And now let's see if I'm okay on my product side. So I only have 1 product, and based on the subscript in this compound of my product, I have 4 oxygen atoms. However, I have 3 molecules of this product. So 3 molecules, each containing 4 oxygen atoms, gives me a total of, I'm on it today, I promise. We have 4 of these product molecules, each containing 4 oxygen atoms. 4 times 4 gives us 16 atoms of oxygen. Okay, so go back and let's check our work. 4 phosphorus, 4 phosphorus, 10, 16 oxygen, 4 by 4, 16 oxygen, 12 hydrogen, 12 hydrogen. Now I am balanced. So I would write this as P4O10 plus 6H2O yields 4 H3PO4s. So I would say this in language: 1 molecule of P4O10 requires 6 molecules of water to react to form 4 molecules of H3PO4, or phosphoric acid. Okay, let's do another one. So SiCl4 solid plus H2O liquid, forming H4 SiO4 plus HCl. Okay, we now need to keep a tally of what's going on where. So let's start with our silicons, just because it's what's written first here. So I have 1 silicon atom on my reactant side. And then looking at my product side, I also have 1 silicon atom. So I have 1 atom Si, 1 atom Si. Looks like so far we are balanced. Okay. Now let's look at our Cls. So I've got chlorine here. And if I count how many there are in that molecule, based on the subscripts, I've got 4 atoms of chlorine. And then looking on my product side, I have only 1 compound that contains chlorine. However, this contains only 1 atom of chlorine, meaning that I need to multiply the number of particles or molecules containing my chlorine on my product side by 4. So I've now quadrupled the amount of HCl on my product side. Okay, let's do hydrogen. So on my reactant side, I have 2 atoms of hydrogen. On my product side, I have 4 atoms of hydrogen from one of my products, and also now 4 hydrogen atoms in my other product. So 4 plus 4 is 8. Atoms of hydrogen, meaning I need to now double the source of my hydrogen atoms on my reactant side, meaning I need to double my amount of water molecules by placing a 2 out in front as a coefficient. All right, now let's do oxygen. Okay, starting on my reactant side, in my water molecule H2O, there is 1 atom of oxygen. However, I have doubled the amount of water molecules, meaning that I have 2 atoms of oxygen in my water. And then looking over here at my product side, let's see here, oxygen. This has 4 atoms of oxygen. So I need to now double my source of oxygen on my reactant side, meaning that I need to replace this with a 4. So I need to double the 2 water molecules and put a 4 out in front. In doing so, I have now affected my number of hydrogen atoms so that I now have 8 hydrogen atoms. And if I look back here at my product side, 4 and 4 is 8 hydrogen atoms. So we are good. I guess this is because I did not recognize that 2 times 2 is not 8. So you could do more simple math if you're a little bit more on fire than I am today, and you'll be good. Oh, guys. We're doing it. We're here. All right, let's look at another reaction. So I have KClO3. By the way, it'd be a good idea for you guys to go back into these notes and name everything. This is going to KClO4 and then just KCl. So let's start with our potassium. So on my reactant side, I have only 1 species, and based on the subscript, I have only 1 atom of potassium. And then going to my product side, I have 2 compounds containing potassium. Each contains 1 atom of potassium per molecule of that compound. So on my product side, I have a total of 2 atoms of potassium, meaning I now need to double the source of my potassium on my reactant side by doubling the KClO3 reactant. So I now have 2 molecules of KClO3. Okay, let's do Cl. So I have only 1 chlorine atom per KClO3 molecule. However, I have doubled the amount of KClO3 molecules, meaning I now have 2 atoms of chlorine on my reactant side. And if I look at my product side, both of my product compounds contain chlorine, so I have this and this. The subscripts in these chemical formulas tell me that there is 1 chlorine atom per compound. So in total, I have 2 atoms of chlorine. Okay, things are looking good. Let's do oxygen. All right, so based on the subscript of oxygen in this KClO3 reactant, I have 3 oxygen atoms present per 1 molecule of KClO3. However, earlier on, I doubled the amount of KClO3, which is going to thus double my quantity of oxygen. So 3 atoms times 2 gives me 6 atoms of oxygen. And then if we look over here, I've got oxygen, and based on that subscript, I have 4 atoms of oxygen. Uh-oh, this means that I am not balanced. So what can I do then? Because if I were to try to, like, I don't know, double this, that would give me 8, which is not 6. If I were to try to double this, that would give me 12, which is not 4. So I need to think of the lowest common multiple, or the smallest number that you get when you look at multiples or products of these numbers. And the lowest common multiple between 6 and 4 is 12. So if I double this, then that should allow me to get somehow 12 atoms on my product side. So now let's double our quantity of 6 atoms of oxygen, meaning I'm going to need to now double my 2 KClO3s. So that's going to give me 6 KClO3s. Sorry, 2 times 2 is 4. Promise I can count and do math sometimes. And you can always check. 4 times 3, 12. Okay. This has affected both my potassiums and my chlorines, so I need to be aware of that. And if I'm looking at my oxygen atoms, there's only one source of oxygen here. So if I were to then triple that, I would then have 12 atoms of oxygen. So now I have 12 atoms of oxygen, 12 atoms of oxygen. And now I need to go back and check that these coefficients give me what I need for my potassiums and my chlorines. So I had 4 potassiums starting on my reactant side. Looking at my first product, that gives me 3. My second product gives me 1. 3 plus 1 is 4, so I'm good with potassium. Now let's look at chlorine. I have 4 chlorine on my reactant side, and now I have 3 chlorines in my first product, and also 1 chlorine in my second product. So that gives me 4 chlorines. So now all of these have been doubled, and I am now balanced. So if I were to rewrite this, I would say that I have 4 molecules KClO3 going to 3 molecules KClO4 and 1 molecule of KCl. Okay, so anytime we are balancing, we're trying to ensure that our chemical equation obeys the law of conservation of matter, and the result of our balancing gives us these whole number coefficients that are written out in front of our molecules that tell us the ratio of molecules needed to react with one another in a particular chemical reaction. So hopefully you guys have a better time counting today than I did. We will practice this more in our active homework. And from there, I would like to move on to our last topic of the day, which is going into the 5 main types of chemical reactions, which we'll explore in more detail coming up later this week. So I'll see you in our last video.